Good afternoon. Today we are discussing about the SYBSc Electronics Chapter 2 Transistors. So transistor is nothing but how this particular type of the semiconductor as well as the electronic device that is to be formed. Basically, the semiconductor is a material we can form that particular type of the electronic devices. And those particular type of the semiconductors are generally used to manufacture those particular type of the transistors of the silicon as well as the germaniums. So using those particular type of the semiconductor materials, either in case of the silicon as well as the germanium, to form that particular type of the transistor is an electronic device. Transistor means a trans plus insulator or the trans plus resistance. Transistor is nothing but that is a transfer of the resistance is there, and how those particular type of the transistors we can form. In last time we can study about the semiconductor device. In case of the diodes we have to be formed in the combination of the N-type semiconductor and the P-type semiconductor. So the formation of the N-type semiconductor is nothing but we can dope the pentavalent impurity to the pure semiconductor in case of the silicon as well as the germanium material, and then the semiconductor material that is to be formed, that is called the N-type semiconductor. While in case of the P-type semiconductor material that is to be formed, if the impurity we have to be doped in the trivalent impurity, and the semiconductor material that is to be formed, that is called the P-type semiconductor material. So as far as the N-type semiconductor material is concerned, the majority charge carriers are the electrons, while in case of the P-type semiconductor materials, the majority charge carriers are the holes. Now, in separately the N-type semiconductor material and the P-type semiconductor material, they has to be sandwiched to each other. Then the PN junction diode that is to be formed. So how those this particular type of the diodes that is to be work in case of the either in case of the forward bias as well as the reverse bias will be there. Due to those particular type of the semiconductor materials, if the diode is supposed to be the forward bias, according to this particular diode, the diode becomes forward bias, maximum amount of the current that is to be flowed due to this particular type of the junction. At the same time, in case of the forward bias junction, the current flow through this particular semiconductor diode becomes maximum. At the same time, the resistance that is to be added into this particular forward bias diode becomes minimum. While in case of the diode is supposed to be connected in the reverse bias mode, if the current that is to be generated in this particular type of the junction is very less, in the range of the microampere range. At the same time, the resistance are to be set up across this particular type of the semiconductor is very high. So due to this particular type of the N-type NPN diodes as well as the PNP diode, now we can manufacture the transistor, or to form the transistor, the two NPN diodes and the two PNP diodes that is to be sandwiched over each other. This is supposed to be the PN diode, and here is another type of the diode that is called the NP diode that is to be formed. Then the transistors are to be formed, that is called as the NPN PNP transistor is there. So according to these three regions of the N-type NPN diode as well as the PN diode as well as the NPN diodes, the transistors can be used three names, that is called as the emitter, base as well as the collectors. So as far as the diagram of this transistor that is to be here, in case of those particular case, this particular terminal is nothing but here PNP diode. This particular terminal is nothing but that is called the emitter. Then this particular terminal is nothing but that is called as the base, while this third terminal that is called as the collector. So according to the three terminals of the transistor, the function of the each terminal will be different. In case of this particular first terminal that is called the emitter, the size of the emitter should be greater than that of the base as well as the collector. At the same time, the doping concentration of the emitter is higher than that of the base as well as the collector. At the same time, the function of the emitter is to emit the number of the electrons from that particular type of the junction or that particular type of the semiconductor material will be there. So this particular terminal that is nothing but for the emitter, and the major function of the emitter is to emit the electrons, how those number of the electrons that is to be emitted, and it should be passed from the base and comes to the collector will be there. Then the second terminal that is called the base. The base is nothing but it is a slightly opposed how much amount of the electronic current electrons are to be generated across the emitter, and that will be opposed to that particular type of the electrons transferred from the emitter to that particular type of the collector will be there. That is why if the base, the size of the base is less than that of the emitter and the collector, while at the same time the doping concentration of the base is also be less as compared to the emitter and the collector will be there. And the main function of the base is to oppose how much amount of the electrons to generate the emitter region and comes to the collector region. That particular type of the regions are nothing but that is called the base region. While the third region that is called the collector region, the doping concentration of the collector is less than that of the emitter and the base will be there, and the size of the emitter collector is greater than that of the emitter and the base, and the main function of the collector is to collect how many number of the electrons are to be generated in that way emitter region and come cross to the base region, comes to the collector region will be there. So due to these three regions and its function according to its doping concentration as well as the major function of the emitter, base as well as the collector will be there. So if according to these three combination, if the transistors are to be symbol like this, in case of the NPN transistor, these three terminal is nothing but that is called the base, here is the collector, and this particular is nothing but that is called the emitter. So this particular transistor is nothing but that is called an NPN transistor, while this symbol of this transistor, this is called the collector, here is the base, and this is nothing but that is called the emitter. The transistor is nothing but that is called the PNP transistor. Now the arrow indicate that the emitter of that particular transistor gives a conventional current flow to that particular direction in case of the NPN transistors as well as the PNP transistor. So in case of the PNP transistor, the conventional current should be flows into the outward direction from the base as emitter base junction becomes forward bias and the collector base junction becomes reverse bias. So that particular amount of the current should be flows into the outward direction. While at the same time, in case of the PNP transistor, the arrow of that particular emitter should be goes into the inward direction, because that will be shows the how much amount of the conventional current flow through that particular type of the current if the emitter base junction becomes forward bias and if the collector base junction becomes reverse bias. So now the transistor that is to be worked into the three regions, that is active region, then saturation region as well as the collector region. Depending upon if the transistor biasing circuits, if the emitter base junction becomes forward bias in all times and the collector base junction becomes reverse bias in the normal case, and then only that particular transistor should be always operated in the active region only. Otherwise, if the emitter base junction is supposed to be the forward bias, then the collector base junction becomes reverse forward bias, then the transistor operating point should be always operated in the saturation region only. While in case of if the emitter base junction becomes reverse bias and if the collector base junction becomes reverse bias, then the transistor should be always operated in the cutoff region, means the transistor is supposed to be the off. So this is not the case as far as the transistor that is to be concerned. How much amount of that particular type of the current should be transferred from the emitter base and it comes to the collector will be there. So in normal case, if the emitter base junction becomes forward bias and the collector base junction becomes reverse bias, then only that much amount of the transistor should be always operated in the active region not in case of the saturation region as well as the cutoff region will be there. So as far as the transistor that is to be concerned, they are having the three terminals that is called the emitter base and the collector. As far as the amplifier concept that is to be used according to the black box, having the two inputs and the two outputs. So for that purpose, if the one terminal should be always common between the input as well as the output will be there. So for that purpose, if the transistor that is to be used in the three configuration, that is called the common base configuration, common emitter configuration as well as the common collector configuration will be there. Now out of these three configurations, common emitter configurations are normally used most of the circuits because of that particular type of the gain of that particular amplifier becomes maximum or higher as compared to the common base configuration as well as the common collector configuration will be there. So depending upon if the transistor is supposed to be as an amplifier, how much amount of the input signal should be transferred to the output signal, because amplifier is nothing but if the weak signal is converted into the strong signal, how much amount of that particular type of the inputs should be transferred from input with respect to that particular output will be there. So as far as those particular type of the transistors are always operating in the active region only. For that purpose, there are the three types of the biasing circuits are to be used, called as the voltage feedback bias, then the collector feedback bias as well as the voltage divider bias will be there. So biasing, what do you mean by the biasing? The biasing is nothing but if the proper flow of the base voltage will be applied to that particular transistor. If the emitter base junction becomes forward bias and the collector base junction becomes reverse bias, then that particular type of the transistors are always operated in the active region, not only in case of the saturation region as well as the cutoff region. So the proper flow of that particular type of the transistor that is to be used. So according to these three terminals of the transistor, that is how much amount of the current flow through this, that is called as the emitter current, then base current plus the collector current is there. If these three currents, if the emitter current should be always equal to the base current plus the collector current, if the base current is very small or it is supposed to be negligibly small, then the emitter current is always equal to or to that particular type of the collector current, because the main function of the transistor in case of the emitter region is the maximum amount of the collector current, maximum amount of the emitter, the electron that is to be generated to that particular emitter region, it should be transferred to the base region and comes to the collector region will be there. So due to those particular type of the concept, this particular electronic device can be used into the so many number of the applications of that particular electronic circuit will be there, and then you can using the amplification factor that is called as alpha, amplification factor that is called as the beta, how much amount of the ratio of that alpha as well as the beta. If the value of the alpha should be less than 1, that is, it is the ratio of the in the collector region to the collector current to the emitter current, and then its value becomes less than 1. It is supposed the 0.99 is there. While in case of the beta value should be the IC upon the IB. If the IB current is very small, then that particular type of the current becomes amplification factor becomes maximum from 20 to the 200 will be there. So depending upon that particular type of the gain, that gain is nothing but that is the output voltage, output divided by the input, either in case of the voltage as well as the current. So by using the amplifier concept, if the gain becomes maximum or becomes increases from input with respect to the output with respect to the input will be there, and so therefore this particular type of the circuit that the transistor is acts as an amplifier, how the weak signal is converted into the strong signal, how much amount of the current that is to be used, what type of the biasing circuit that is to be used into that particular type of the circuits are there. That is nothing but other than transistors. And so using both those particular type of the transistor that is to be used into the its transistor characteristics, that is your input characteristics, output characteristics. If the output voltage should remains constant, whatever amount of the input will be input voltage with respect to the input current that is to be changes, and we can find what is the input resistance of that particular resistance will be there. Similarly, we can find if the input voltage current becomes constant, if the output voltage with respect to the, we can take the current, then we can find what is the output resistance of that particular resistance. If the input resistance becomes less, while the output resistance becomes input resistance becomes maximum, while the output resistance becomes minimum. To that particular type of the characteristics, we can find how much amount of the input as well as the output resistance of that particular transistors are to be there. So using those particular type of the concept, as per the transistor characteristics, as per the transistor is as an amplifier, or if suppose the transistor is actually supposed to be the switch, depending upon what type of the voltage that is to be applied between the emitter with respect to the base. If the suppose the transistor is actually supposed to be the switch, if the input voltage is supposed to be the zero, then the input and the emitter base junction becomes reverse bias. Then if the junction becomes reverse bias, if the transistor becomes off, and if the switch becomes off, then whatever amount of the voltage will be applied, that voltage will directly coming to the collector, because collector current becomes zero. And then that particular type of the situation, if the transistor is supposed to be the off, and if the switch is supposed to be the off condition. But if the input voltage is applied to the base of that particular transistor is supposed to be the 5 volt, then according to the base voltage of that particular emitter base junction becomes forward bias. And if the transistor becomes conducting, if the transistor becomes conducting, if the switch becomes on, and if the switch becomes on, whatever amount of the voltage that will be applied from collector base and comes to the collector current becomes maximum, but the collector voltage becomes minimum. And in that particular situation, if the switch becomes closed, maximum amount of the current that is to be generated across that particular type of the transistor will be there. So in those particular type of the concepts, we have to be used the transistor in the so many number of the applications in the electronic devices, and using those particular type of the electronic devices, we can form the integrated ICs, because IC that is to be manufactured in the semiconductor devices, that is a transistor diodes, as well as the UJT, as well as the APT, that is to be manufactured by using those particular type of the use, and a number of the component that is to be compact in a very small area. That particular type of the circuits are nothing but that is called the integrated circuit will be there. And using those particular type of the integrated circuit, there are so many number of the advantages of that particular integrated circuit will be there, because its size is small, its power consumption is very small, and they can require maximum amount of that particular work function, as well as its work efficiency becomes maximum to that particular type of the electronic devices will be there. And so therefore those particular type of the device that is to be used into the integrated circuits in a large scale industry, as well as in the laboratories are there.